Welcome to Tomorrow Unveiled. Have you ever wondered if the energy future we've, been imagining is about to take a really dramatic turn? Because this past week, wow, it delivered a seismic set of developments that could truly redefine how we power our world. Today, we're taking a deep dive into what our dedicated research team has termed green code hot core. And this isn't just about different energy sources, it's about a powerful convergence of forces. We're seeing this accelerating pivot towards high density, dispatchable, and crucially domestically fueled energy. Think advanced nuclear fission, fusion, enhanced geothermal systems, and high density energy storage. So our mission today is to unpack the most significant breakthroughs, the investments, the policy shifts from just the last 7 days, all pushing these hot core technologies firmly into the spotlight. You're about to hear about some groundbreaking projects, some surprising new economic models, and, well, a pretty clear strategic shift in global energy.
It really has been an incredibly dynamic week, almost like you said, seismic. Perhaps an inflection point. The information we've compiled, it really showcases a deep reevaluation of energy priorities. It seems like we're moving beyond just looking at carbon emissions, though that's still vital, obviously, but now also prioritizing reliability, security, and the sheer density of energy production itself.
Exactly. So let's really dig into that. The dawn of high density energy and some of the major breakthroughs from this week. Starting with fusion. I mean, for years fusion felt like science fiction, right? Always 30 years away. But what happened this week, it genuinely suggests a new era might be starting. Okay, get this. Imagine a future where fusion not only powers our homes, but potentially creates gold.
Uh-huh.
That's a real claim emerging now. Our team tracked some incredible developments, including Helion Energy. They began physical construction just days ago in Washington State on what could be the world's first commercial fusion power plant, Project Orion.
That's right. And their goal, it's ambitious.
Very ambitious. 50 megawatts of power to Microsoft data centers by 2028.
Yeah, and that Microsoft connection, it isn't just a big deal for Helion, though it obviously is. It's a calculated, very public bet by a tech giant on fusion's commercial viability. It signals that, for a company with these immense energy demands, the perceived risks of fusion, they're now being outweighed by its potential as a reliable, clean power source. It's the first ever fusion energy offtake agreement. A true milestone.
A huge milestone. But then you mentioned gold.
Yes. Well, in contrast to that very concrete deal, our research also highlighted something else entirely, something being called the Marathon Fusion Gambit. This involves a really striking, almost alchemical claim, like you said, transmuting mercury into gold as a fusion byproduct, potentially adding over, get this, $500 million in annual revenue per gigawatt.
Wow. Okay, that's quite something.
It is. And it's not just a fascinating claim, right? It illuminates the lengths some fusion companies might be going to, trying to create these non-energy revenue streams. It reveals the immense capital challenge they face, and maybe the creative or perhaps speculative financial models needed to bridge that gap from lab to commercial viability.
So quite a spectrum then. From a tech giant making a solid energy deal to claims that sound, well, almost like ancient alchemy. But then in stark contrast again, the research team also details a more, let's say, sober path, pulsed power inertial fusion, specifically a method called MagLIF.
MagLIF, right? Magnetized liner inertial fusion.
Yeah, that's it. This sounds like the unglamorous but maybe absolutely essential work, using powerful electrical pulses, compressing fuel within a magnetic field, and the research indicates it could achieve a net facility gain maybe 100 times greater than current facilities, like the National Ignition Facility.
And here's the kicker.
Go on.
At potentially just 1/10 the capital cost.
1/10 the cost. Okay, that's significant.
Exactly. What's truly fascinating here is that dichotomy you pointed out. One approach is aiming for this, maybe, revolutionary financial breakthrough via byproducts, gold, no less. While the other focuses on fundamental engineering efficiency and cost reduction, it really shows fusion grappling with both attracting massive investment and solving these core physics and engineering challenges that are maybe less flashy, but absolutely critical for real-world viability.
Right. So building on these incredible advancements in fusion, advanced fission is another hot core technology. And it also saw significant breakthroughs this week, pushing it firmly from blueprint to deployment. It feels like it's no longer just a concept, it's becoming a global reality, especially with these smaller modular designs, right?
Definitely. The SMRs, the small modular reactors, and microreactors.
Take the U.S. Department of Defense's Project Pele. That's a great example. We noted they began fabricating the reactor core for the first U.S. microreactor prototype just last week, July 25th.
Physical hardware.
Exactly. Moving a transportable 1.5 megawatt electric microreactor from design into actual physical hardware, and they're targeting 2028 operation for military bases. This really exemplifies that hot core philosophy: high density, dispatchable, domestically fueled power, engineered for specific high-value uses.
It's clearly a strategic move, showcasing microreactors for national security applications, places where reliability and a small footprint are absolutely paramount. But this momentum isn't just in the U.S. We're seeing strong international collaboration, particularly what's been termed a Nordic nuclear renaissance, in Norway, for example.
Norway. Interesting. What's happening there?
Well, two significant agreements popped up. First, Trondheimslige Kjernekraft AS partnered with Korea Hydro and Nuclear Power KHNP. They're going to study building multiple 170-megawatt electric ISMRs Korean design.
Ugh, multiple reactors.
And second, Ocean Power, along with Copenhagen Atomics, they're going to study thorium-based molten salt reactors. Get this. On floating barges.
Floating reactors.
Floating reactors, designed specifically to consume existing nuclear waste and breed new fuel from thorium.
Wow. That's incredibly innovative, using waste as fuel and breeding new fuel. And then you layer on the geopolitical dimensions. The research team flagged that Russia-Niger deal, Rosatom and Niger signing an MO.
Right. On peaceful nuclear energy, including plans eventually to build nuclear power plants.
It feels like a very strategic move for Russia, doesn't it? In a uranium-rich nation like Niger. It really highlights how nuclear technology is, well, a foreign policy tool, and how these technologies get woven into global power dynamics.
Absolutely. And it's not isolated. We also saw global growth continue. China's Hualong 1 reactor at Taipingling hit a construction milestone, and progress continues, albeit slowly, at the UK's Hinkley Point C project.
So a lot happening in fission. But beyond nuclear, this week also brought significant advancements in high-density storage and geothermal. These seem crucial, proving they're fundamental to a reliable grid.
They really are. And it raises an important question, doesn't it? How do we ensure stability and supply for critical new demands, like especially artificial intelligence? Energy storage, its role is shifting. It's not just about integrating renewables anymore. Now it's absolutely crucial for grid stability, for capacity, for reliability overall.
And the breakthroughs there are genuinely exciting, too. Researchers at KOST, King Abdullah University of Science and Technology, they unveiled a simple fix using sulfate salts. Just sulfate salts, to extend the life of aqueous batteries tenfold.
Tenfold, that's huge for grid applications.
Imagine the impact on grid reliability, on cost effectiveness, if that holds up at scale. Meanwhile, scientists at WPI, Worcester Polytechnic Institute, they debuted a clean method to transform spent lithium-ion batteries into new cathodes, recovering 92% of critical metals.
And significantly reducing emissions in the process. That's key.
Right. These electrochemical breakthroughs, they feel like game changers for creating a circular economy and energy.
Definitely. And the market signals are strong, backing this up. New York just issued a request for proposals for 1 gigawatt of new bulk energy storage. And DTE Energy in Michigan, they're discussing 7 of new load with data centers.
7 gigawatts, just for data centers.
Just for data centers.
Okay.
And they're explicitly linking storage to the reliability needs of these massive industrial consumers. This data really highlights how storage and enhanced geothermal systems, EGS, are being reevaluated. They're being seen as foundational elements now, not just complements to wind and solar.
Right, especially EGS powering AI's brain, as some are putting it. That symbiotic link between enhanced geothermal and AI, it seems to be strengthening. Fervo Energy, for instance, they're positioning EGS as the ideal 24/7 clean power for AI data centers, like those planned in Utah.
And that provides the crucial long-term power purchase agreements, the PPAs. Those are absolutely needed for financing these big EGS projects. It shows how these reliable power sources are becoming critical for these emerging, really energy-intensive industries.
Makes sense. Reliable power for reliable AI.
And the technical progress is helping de-risk the subsurface, too. There are advanced simulations now of something called discrete fracture networks, DFNs, essentially mapping the complex underground cracks and pathways where the geothermal fluids circulate. This helps model the EGS reservoirs much better, reducing geological risk and improving the viability. It's that essential foundational work that makes these ambitious projects more feasible.
Okay, so let's shift gears slightly to investment and policy, because this past week truly revealed, I think, a decisive global pivot here, too. Starting back with fusion, the funding has surged, but the capital challenges are still immense.
Absolutely. The Global Fusion Industry Report, the 2025 edition, it shows an unprecedented surge. $2.64 billion raised in the last 12 months alone. That's a 178% increase over the previous year.
Wow, 178%.
Yeah, bringing cumulative funding now close to $10 billion overall.
10 billion sunk into fusion so far. And big tech is getting directly involved providing these critical revenue anchors, right?
That's key. Google, for instance, signed a 200-megawatt offtake agreement with Commonwealth Fusion Systems, and Microsoft's partnership with Helion, as we mentioned, includes that 50-megawatt offtake. These corporate commitments are vital for moving fusion beyond just pure research into commercialization.
These are real significant bets by major corporations. That gives it weight. But despite this surge, the data our team found also shows, 83% of fusion firms still say they need more capital.
That's right. A median of about $700 million each is needed just to reach pilot plant operation. So yes, it's an exciting time, lots of investment flowing in, but the capital challenge is still absolutely immense.
700 million each. That's a lot of money still needed.
It really is. And then you look at the U.S. policy pivot. It's quite striking. Seems aggressively pro-nuclear, pro-hot core, while at the same time, low-density renewables face new headwinds.
Yeah, tell us about that.
Well, the U.S. Department of Energy announced new pilot programs. 1, to fast-track advanced test reactors. 2, to build domestic production lines for advanced nuclear fuel, HALE.
HALU, high-assay, low-enriched uranium. We'll come back to that.
Exactly. The aim is explicitly to end reliance on foreign sources, particularly Russia.
Okay, so pro-nuclear actions. But you said headwinds for renewables.
Yes. It really feels like two different policy landscapes emerging in the U.S., explicitly favoring these high-density, hot core technologies. Analysts noted a Senate bill proposing to phase out tax credits for wind and solar projects after 2025 or 2027, and significantly introducing an excise tax on projects using foreign components, especially pointing towards China.
Ouch. That sounds like it would have a real market impact.
It already has, apparently. Over $22 billion in clean energy projects, mostly battery, storage, and EV-related, were canceled or scaled back in just the first half of 2025. The reason cited: policy uncertainty. And our research also highlights that the current administration canceled plans for new offshore wind farms and ended preferential treatment for wind and solar development on federal land.
Wow, okay. That is a stark divergence.
It really is. And if we connect this to the bigger picture, it's not just about energy technology choices anymore, is it? It's about geopolitics. It's about supply chain security. The focus seems to be clearly shifting towards what can be produced domestically, reliably, securely.
Right. And this shift isn't just happening in the U.S. policy space. We saw monumental shifts in global capital flows, too, didn't we? Major institutions now backing nuclear for development and security. That World Bank decision, calling it a momentous shift on July 31st, reversing its decades-long ban on financing nuclear power projects, that's huge.
It is absolutely massive. They're explicitly prioritizing accessibility, affordability, and reliability now.
Does this shift effectively level the playing field, then? Does it give developing nations a real alternative, an alternative to the state-backed loans from, say, Russia or China, which have often been their only options for big energy projects?
I think it absolutely does, or at least it aims to. And this move seems coordinated. The IAEA, the International Atomic Energy Agency, also released an outlook on nuclear power for development in Africa, specifically highlighting the potential for SMRs on the continent, projecting a 5-fold growth by 2050.
5-fold growth in Africa.
Yeah, so it raises this really important question about how developing nations will choose their energy path going forward, and crucially, who they will partner with, now that more multilateral financing options might be on the table for nuclear.
Fascinating. And the private sector is showing confidence, too, even outside these big institutional moves.
Yes, in India, for example, Avada Group plans to invest $600 million, not just in 1 gigawatt of renewables, but also in battery energy storage systems, BESS. It demonstrates a clear recognition, even from renewable developers, that firm dispatchable power is key. Even when paired with intermittent sources, you need that backup, that storage.
Okay, let's talk sustainability impacts, because it feels like the definition of sustainable is broadening here. Life cycle benefits like recycling and waste reduction seem paramount now.
Absolutely. That WPI breakthrough in battery recycling we mentioned earlier, recovering 92% of critical metals and regenerating them into high-performance cathodes. That effectively starts to close the loop on battery supply chains. It slashes manufacturing energy, reduces emissions. It's a critical step towards resource efficiency and a truly circular energy economy.
A huge win for sustainable materials, definitely. And then there's the nuclear waste reduction side. You mentioned thorium molten salt reactors designed to consume existing waste.
That's right, consuming the transuranic waste from existing reactors, the really long-lived stuff, and at the same time breeding new fuel from thorium, which is much more abundant than uranium. This could drastically shrink the volume and the longevity of nuclear waste, essentially turning waste into fuel, addressing one of nuclear energy's biggest historical challenges head-on.
Okay, that sounds very promising.
It does. But it raises another important question, doesn't it? Beyond the technical advancements, how do these technologies align with societal values, with equity? What's fascinating here is seeing sustainability become this multi-factor equation. It's beyond just carbon emissions now.
So things like safety, land use.
Exactly. High-density sources like SMRs offer carbon-free 247 power. That's a big plus. Plus, they often incorporate passive safety features, designs intended to prevent meltdowns without active intervention, and siting flexibility. You could potentially put them underground in remote areas. They're generally touted as safer than older, full-size reactors. And, of course, the land use. Minimal land footprints compared to sprawling wind or solar farms needed for the same energy output.
Minimal land use is a big selling point. But as our research highlights, community engagement is absolutely critical, isn't it? There's a real need for public education, for input to address concerns, the reactor in my backyard fear, or worries about induced seismicity for EGS projects, drilling deep underground.
That's crucial. These social dimensions are just as important as the technical ones for widespread adoption. You need that social license.
So what about the broader social and economic dimensions?
Well, the promise is clear. High-density projects offer reliable electricity. That underpins economic development, boosting education, industry, quality of life, especially in underserved regions. Think back to that Niger example. However, these are complex technologies. They require highly skilled labor forces, robust regulatory institutions. So there's a big emphasis needed on training specialists, building capacity.
And public acceptance. Nuclear still faces skepticism, right? Even if support is growing.
It does. Transparency is key. Rigorous safety demonstrations are non-negotiable. And tangible community benefits, jobs, local investment, stable power, those are crucial for building and maintaining that social license to operate.
Okay, let's do a quick comparative analysis then. High-density advances versus these low-density headwinds we talked about. Despite all this buzz about hot core technologies, wind and solar are still growing globally, right?
They are. That's important context. Our research shows they're on track to cover over 90% of global electricity demand growth in 2025. And their costs are generally at all-time lows globally.
90% of growth, that's still huge.
It is, but as we discussed, the U.S. market paints a different story right now.
Yeah.
That sector faces rising headwinds, tariff escalations, uncertain federal policy, leading to those record project cancellations. So it's not just a technology choice, it's becoming a strategic one with national implications, particularly in the U.S.
And this is where it gets really interesting, I think. We're seeing this fundamental strategic choice emerge, not just between different technologies, but between two fundamentally different grid architectures for the future. You've got what our team calls the green code grid.
Right. Land and material intensive. Requires vast areas for generation. Massive transmission build-outs to connect remote resources to cities. An unprecedented scale of energy storage to handle intermittency, and often relies on supply chains dominated by just a few countries.
Okay, that's the green code vision. Then there's the hot core grid vision.
Exactly. If we connect this to the bigger picture, it suggests a profound shift in how we value energy attributes. It's not just about what's cheapest per kilowatt hour generated anymore. It's about what provides reliability, security, resilience to the entire system. So the hot core grid, minimal land footprint, can often be sited closer to load centers, reducing transmission needs, produces firm 247 power, inherently stable, reduces the need for vast amounts of storage compared to a grid dominated by intermittence. And its fuel sources, uranium, thorium, terrestrial heat, can potentially be secured domestically or from diverse allies, enhancing energy security, maybe even geopolitical leverage.
So policymakers are increasingly weighing these systemic differences then. And this pivot towards hot core that we're seeing, it looks like a strategic bet, a bet on reliability, energy security, and a smaller physical footprint.
That seems to be the direction things are heading, yes. But looking ahead, the outlook, the timelines, the challenges, they're significant. Let's be realistic. For SMRs, for instance, widespread commercial adoption for grid-scale power, probably early to mid-2030s. Even as those military projects target 2028. Getting them commercially competitive at scale is another story.
And the challenges.
Proving performance and cost at scale, handling novel waste streams, even if reduced, transporting and securing factory-built modules. The HALEU fuel supply bottleneck we mentioned, high initial costs for first-of-a-kind plants, slow regulatory processes, political shifts, potential public opposition. It's a long list.
But there are mitigating factors too, right? Things being done to address these.
Yes. First-of-a-kind demonstration projects are crucial for learning. Federal R&D is focused on waste solutions. We need clear transportation regulations. Long-term PPAs, like the Microsoft or Google deals, provide revenue certainty, government financial support, loan guarantees, efforts to reform the NRC, the Nuclear Regulatory Commission, to speed things up safely. International regulatory harmonization could help. Bipartisan political consensus would be huge, and transparent public engagement, as we said.
Let's circle back quickly to that HALEU bottleneck. High-assay, low-enriched uranium. How critical is that?
It's a critical near-term bottleneck, especially for the U.S. advanced reactor pipeline. This fuel, slightly more enriched than traditional fuel, is vital for most of these new U.S. designs to work efficiently and safely. But right now, a commercial-scale production capability just doesn't exist in the U.S. or among its allies. Russia is currently the primary commercial supplier.
So that DOE pilot program to build domestic HALEU lines is absolutely crucial then.
It's a strategic imperative, no question. But building a full, resilient supply chain, that's a multi-billion-dollar effort, likely taking a decade or more. It's a key piece of the energy independence puzzle for these technologies.
Okay, so wrapping this all up, what does this all mean for the future of our energy supply? This hot core pivot, it feels like a genuine structural shift, driven by, well, the physics of energy density, yes.
Physics, absolutely. But also geopolitics, as we've discussed. Industrial demand, especially from AI needing reliable power, and the fundamental need for grid stability as we decarbonize.
And the long-term vision.
The long-term vision, say by mid-century, is that high-density energy could be a cornerstone of a decarbonized, truly abundant energy system, enabling new frontiers, maybe things like large-scale production of synthetic fuels, direct air carbon capture, massive desalination projects, things that need huge amounts of reliable energy.
So not necessarily replacing renewables entirely, but forming a backbone.
Exactly. The future will likely see a backbone of nuclear, maybe eventually fusion plants, providing that reliable, clean baseload and dispatchable power, augmented by vast arrays of renewables and storage, playing their role when the sun shines and the wind blows. But the starting gun for the hot core future, with all its challenges, it feels like it has unequivocally fired this past week.
What a week. We've covered a truly transformative period in the energy world. Seeing these hot core technologies, advanced nuclear fusion, enhanced geothermal move from aspiration towards tangible reality, backed by significant investment and, crucially, major policy shifts. We also saw that stark contrast, didn't we? Low-density renewables facing new headwinds, particularly in the U.S. market, underscoring the strategic reevaluation of how we build the grid of tomorrow. Now, if you're finding this insightful on YouTube, please do take a moment to like this video, subscribe to Tomorrow Unveiled, and be sure to turn on notifications so you never miss an update on the future. And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It really does help us reach new listeners who are curious about these topics. And we love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment. Let us know what you think about Green Code. Hot core this week in energy. Do you see the energy landscape shifting as dramatically as our research team suggests? We want to know your take.
And perhaps a final thought to leave you with as we look to the future. Consider this. Beyond the tech, beyond the policy, what role will that social license to operate ultimately play in determining which of these powerful energy technologies actually wins the race to power our world? It's not just about what's technologically possible, is it? It's also, perhaps fundamentally, about what society embraces.